Welcome to the Journey Shake Cam. Well, today we are starting a new subject, and you know how excited I get about that. Well, to start us off, we need to know our decompositions. So we're going to review those in the warm-up. So do the best you can, and I'll see you in a moment. In number 1, we have one of my most favorite compounds, potassium chlorate. And whenever we decompose a metallic chlorate, we always are going to get oxygen. And therefore, when I remove the oxygen, I am also going to get the metal chloride when I take out the oxygen. Once I have my products, then I just have to balance the number of atoms. Well, there are 3 oxygens here and 2 oxygens here, and the common multiple would be 6. Therefore, I need 2 potassium chlorates and 3 oxygens. Well, as soon as I add the 2 in the front here, then I need 2 of the potassium chlorides, and then it's balanced. In the case of an oxyacid, I must find the charge of this non-metal. However, when I decompose any oxyacid, I will always get water. So I write the water first. Then I get some form of the acid anhydride, and that would be NO. Now, to know exactly which formula it would be, I have to find this charge. And oxygen is -2 times 3 is -6. Hydrogen is +1 plus X equals 0. And therefore, X is equal to +5. Now, sometimes we do it just using the polyatomic ion. Nitrate has an overall charge of -1. And oxygen is -2, and there are 3 of them. That gives me a -6. Now, because this is a polyatomic ion, it has an overall charge of -1, and therefore nitrogen is +5 in both cases. And if it's +5 here, it must be +5 here. And oxygen in the negative position will be -2. The common multiple between 5 and 2 is 10, and therefore I must multiply the 5 by 2 and the 2 by 5 to get +10 and -10, because compounds are always equal to 0. And now that I have 2 nitrogens here, I must put a 2 coefficient here, and then it's balanced. And that's how you do number 1 and 2. In number 3, we are decomposing magnesium carbonate, a metallic carbonate. Magnesium carbonate. Now, magnesium is +2 and carbonate is -2, so it's just written simply like this. Now, the common molecule I get out of this compound is carbon dioxide and the base anhydride, and then it's balanced as well. And finally, I have magnesium hydroxide. Now, I must always make sure that my compounds are equal to 0. And magnesium is +2 and hydroxide is -1. And that's why I need 2 hydroxides to get +2 and -2 to be equal to 0. Now, whenever I decompose a metal hydroxide, we call this a base, as you will recall. And bases will always give me water and the base anhydride, which is the metal with oxygen. And then that one's balanced as well. Now we're ready to start talking about something new, and I'll be right back. Now we need to look at topic 12, worksheet A, and we're going to go through the sample problem together. However, before I begin that, we need to talk about standard molar volume. Standard molar volume. Now, we've used the word standard before. standard temperature and standard pressure. And that's why we call this value that we're going to talk about standard molar volume. 1 mole of any gas. And why do we say any gas? Because we, from gases part 1, determined that we treat gases as though they were ideal. So it doesn't matter which gas that I have. And 1 mole of any gas is equal to 22.4 decimeters cubed. 1 mole of any gas is always 22.4 decimeters cubed at STP. This value is only true at standard temperature and pressure. 1 mole of any gas will always occupy 22.4 decimeters cubed at standard temperature and pressure. And we're going to use that. Do you remember when we were doing mass, pizza? Well, today we're doing mass volume. And the process is very much the same, only the last step is different because instead of changing back to mass, I'm changing to volume. So let's look at that first problem that we have on the worksheet A. The first step we must always do is get our balanced equation. And we had this equation in the warm-up. We have 2 potassium chlorate will produce 2 potassium chloride and 3 oxygens. Now, I'm given in the problem that I have 10.5 grams, and I want to know what volume of oxygen will be produced. Therefore, I take my 10.5 grams of my potassium chlorate, and this is one big long conversion. And 1 mole of potassium chlorate has a mass of 122.6 grams of potassium chlorate. I need to make sure that my units will cancel. Now let's go over the AMU one more time. We have potassium is equal to 39.1. Chlorine is 35.5, and we have 3 oxygens, which is 3 times 16.0. I write them again, and then I add them all up, and I get 122.6 grams per 1 mole of KClO3. And that's the number that I have here. This changes my grams to moles. Now, in order to change from one compound to the other compound, I must use the balanced equation. This is my recipe. And it is only this middle step when I'm changing compounds that I use this. And what I'm looking for goes in the top. There are 3 moles of oxygen for every 2 moles of potassium chlorate. And then the final step is what is different in this new material. There are 22.4 liters of any gas, and in this case we're talking about oxygen, in 1 mole of oxygen. And when we do the math, we get 2.8776. Again, I look back to my original equation and I want 3 significant digits in my answer. And then I look at the 7, it rounds the 7 up, and it's 2.88. Oh, I used liters here. So the liters and decimeters cubed are interchangeable. 1 liter equals 1 decimeter cubed. And therefore, this would be 2.88 liters of oxygen, or 2.88 decimeters cubed of oxygen. Would be the same answer. And that's how we do the sample problem. Now you can do the rest of the problems. Just follow the process that's given to you at the very beginning. First you get a balanced equation. Then you change your grams to moles using the AMU, the gram formula mass. Then you use your mole ratio to find your unknown compound, and then you change it back to volume using standard molar volume. You can do that. That's no problem. I'm sure that you'll have fun doing this. Well, I can't wait to see you tomorrow. Bye.